Hey, Math 206. I've already done a few constructions, and this one is my favorite because it's just very visually pleasing, I think. How do you construct a circle that's circumscribed about a triangle? So what it means for the circle to be circumscribed about the triangle is that the circle contains the three vertices of your triangle. And the triangle is completely inside the circle. All right, so in order to do that, what we want to do is find the center of the circle. If we know what the center of the circle is, then we can find the radius of the circle by just measuring the distance from the center to any one of the vertices. Because if this is the center of the circle, then the distance from the center to A should be the same as the center to B, should be the same as the center to C. All right, so all we need to do is find that center. Basically what that is the point that is the same distance away from B and C, also the same distance away from C and A, and the same distance away from A to B. So any point that is equidistant to the endpoints of the line segment is on the perpendicular bisector of that line segment. So basically what we can do, if we can find the perpendicular bisector of, say, side AC and the perpendicular bisector of side BC, then wherever those two perpendicular bisectors meet will be the center of the circle. So that's exactly what we're going to do. We will construct the center by constructing the perpendicular bisector of AC and then also the perpendicular bisector of BC. So let's try it here on this triangle. So step one would be to construct the perpendicular bisector of side AC. So the last video showed us that in order to do that, we basically will set our compass a little bit more than halfway, and you can draw an arc above and below the line segment. Then we take the compass point and move it to the other side. Same length, draw an arc. All right, we can connect these. This is like P and Q here in the language that we were using before. Connect P and Q by a line segment, and there I have one perpendicular bisector. Then I'll do the same thing for side BC, only I don't want my constructions to get really ugly. So I think what I'll do is I will just construct two intersection points on this side of the line segment instead of one above and one below, because I don't want my image to get really messy. All right, so setting my compass a little bit more than halfway. I'll make an arc emanating from B, same length set. Make an arc emanating from C, and I have my first intersection point. And I'll open my compass just a little bit larger, make an arc from one side, and then the arc intersecting that arc from the other. And now I have these two intersection points. You can again call them P and Q if you like. And be very careful. I'll connect the dots. All right, so these two perpendicular bisectors intersect right there. So I'm not even going to draw the point because it might mess up my perfect drawing here. So there's where they intersect, and that is, I'll call that O, the center of my circle. So now what you can do, take your compass and set it to the distance from O to any one of these three vertices, notice that that distance should be the same. So if you put the compass point at that intersection point at O, you should be able to reach vertex C, vertex B, and vertex A. Then the only thing left to do is to draw the circle. Oops. And it's perfect. It's a circle that contains each vertex, A, B, and C, perfectly.